This question is the 2017 higher level question C1 Geologic Geometry, and looking at the question in comparison to the other questions on these papers, this is quite wordy. It's generally quite long, but that's just information that is there that can't really be given in the drawing. So as usual, the contour map is on the back of section A, and the question then is in the first question in section C. So there's three kind of distinct parts to this question. We've got what is a traditional road geometry piece down here, except it's phrased as a ski run. We've got a profile and finding out information about pylons or something like that, again quite common. And then finally boreholes down here. So there's three kind of distinct parts to these questions, so I'm going to take them separately. So the first part, part A, ABCD is the center line of the ski run. The ski run has the following specifications. Portion of the ski run from A to B, so here to here, is level at an altitude of 65. The portion of the ski run from B to C, so from B here down to C, is falling. Uniformly to a level of 50 meters at C, so at B it's 65, at C it's 50, so that's a change in altitude of 15 meters between the two. And then finally from C to D is level at an altitude of 50 and is widened on the northern side as shown, so it gets wider up here, so we're going to have to take that into account as well. So using slopes for 1 and 1.5 for the cuttings and 1 and 2 for the embankments, complete the earthworks necessary for the ski run between A and D on the northern side, and we don't need to do anything for the southern side. So we've got 5 meter contours, and from here to here is going to be level, so our lines for our height lines come out are going to be parallel to the edge of the road. The height of the road is at 65. The contours above in this area, they're all larger than it, so we're going to be cutting it away, which means we're going to be using a side slope of 1 and 1.5. So for every 5 meters height that we're going up, we need to push the ground back 7.5. So I'm just going to mark that out here. So each of these has a corresponding height, a contour. So the edge of the road, that's at 65. Next one is 70, 75, 80, 85, and 90. So I don't actually need the last one. So now each time a contour hits the side of the road, or every time a contour hits the corresponding height line, so this 70 contour hits the 70 height, it's 70 here, 75, 80, 85, 90, 90 again, 85. Now I know this area here is kind of going into the area that I'll probably be working over here, so we just need to figure out where they're going to cross over. So I'm just going to draw this in lightly first, as they may transition into the piece that's not level. Okay, so the piece that this is falling, so we're going to have a look at that part of it now next. So looking at this part of the road here, B is our high point at 65, C is our low point at 50, and there's a change in altitude here of 15 meters. Okay, so 3 intervals. So what that means is we're going to have to put in our cone. As it's a cut, it's going to be an inverted cone, and the inverted cone goes on the lower point of a cut. So we're going to put that down here off of C, and it is going to be 3 times the distance that we step out. So 7.5 times 3, because we've dropped 3 distances. So we've dropped 5, 10, 15. So we step out 7.5, 15, another 7.5. So we're going to add all of those together. So the 3 of those together are needed. So that's where we're going to get the radius for our inverted cone. So we are looking for 22.5 out along this way for the radius of our cone. And using a compass. And again, we can draw in our height line. So it starts at B, goes along this cone here, the inverted cone here. That piece of the cone is at 65. So you can take a height line out along this way here, and that one is at 65. All other lines are going to go parallel to that now, so we'll treat it essentially like it's the side of the road. So stepping out the same distance as 7.5 in either side. So parallel to that, just like the other ones. So this is 60, and this one here is 55. And then the edge of the road there at this point, that would be 50. So working out the other way, so 70, 75, 80, 85, and I need one more just for 90. So 90 again, label them, and 65. So again, each place a contour hits or crosses the corresponding height line is a point on our cut. So this is the 60, 65, 70, 75, 80, 85 here, 90, and then we've got 90 kind of in here again. So they both meet at that same point, or close enough to it. So our curve starting on 50, because the 50 contour happens to go through point C, side of our cut here, the shape of the ground, is this here, and we see that transitions into this one just at that point. So then this is where this one kicks in. So that would be coming down along this way. So that's this part here. This is our cut. So we have it horizontal at this point, and it's inclined in this section off over here. Final part of this then is doing basically the same thing over here, except this time the road is going off at an angle. We've got this time the height of the road is at 50. All the ground around this part of it is less than 50, or it's not a road, sorry, the ski run. All the ground at this point is less than 50, so we're going to be building up the snow. So it's side slopes of 1 and 2 as given in the question. So stepping out distances here, so for every 5 meters that we go down in height, we have to push the ground out 10 to build it up properly. So that's 50 here, 40, sorry, 45, 40, 35 and 30. So parallel to the side of the road here. Again, label them. So side of the road is 50, this is 45, 40, 35 and 30. 2 30s out here, 35 and 35, 40, 45 here, and we got 40, and just continue this over. That's 45 here. Now that would be if this continued straight on this way, which it doesn't. It's sloping, it's turned in this way, so we're going to need to take that into account. Again, it's the same idea. So stepping out again parallel to the side of this ski piece. It is horizontal, it's level, so there's no cones to be dealing with. So coming out along here again parallel to the side of the ski run. So that was 50, 45, 40, 35 off out here. Yeah. So in here at the side of the road, or side of the ski run, that's our point here. The next line out, so we had 50, 45, 40 and 35. Marking our points out, this point here is 45, 40 and 35 off out up over there. So where this line crosses through the one going the other way, so where it crosses through this line here, is the transition for where it's going around the corner. So this point here is the point where they cross over. So we can darken in the shape of the snow coming along here. Now just the final thing is there's an edge here as it changes direction, so just draw a line joining from this corner of the snow run down to where these two edges joined off each other, just to mark the change in direction that's there. And that is the first part of this question. That's part A of this question. Part B of this question is looking at the profile section up here. So in the space provided at the top of the map, draw the vertical section of profile through the ski run on the line EF. So going from here to here, EF. Vertical towers constructed at points E and F support a steel cable for a ski run or ski lift. The cable is 15 meters and 20 meters above the ground at E, so 15 at E, 20 at F. Determine the maximum vertical distance between the cable and the ground, and we can assume that it's straight, that it's not drooping anywhere. So we're going to start by drawing the height of the ground, the profile. Okay, so they give us a line here to start with, which is 35. Sorry, it's at 50. So we're going to go up in our 5 meter intervals above and above that. 25, 50, 55, 60, 65, 70. I'll drop along that way. So just after labeling, that to speed this video up a bit, going to locate point E, or the tower at E, so that's up along here somewhere. Same thing for F. Now we need to draw the ski run. So the ski run is horizontal at a height, or it's level at a height from A to B at 65. So we're going to locate point B. It's off up here. So this is the ski run along this part at B, so that's point B. At C, it's at a height of 50, so that's this point here, and then it becomes level again, and then it's falling uniformly from B to C, so that means the ground looks like this line here. Finding the towers, at E, we're told that it has a height of 15 meters, so it's 15 meters above this. That's going to be up at a height of 80, so that's point E up here. And at F, it's 20 meters above the ground, so that's going to be at a height of 70 down here. So we can draw a straight line joining E to F. sorry, I marked E there in the wrong spot. E is back here, not directly above B. So from here to here, can draw a straight line. That would be the cable between the two. And now we need to find the highest height between the cable, which is this line running along this way, and the ground. So this is probably its narrowest point, okay, and it's getting wider. These are not parallel, so it's getting wider as it moves down along this way. And here again, because this level is off, they're starting to get narrower. So at this point here is its widest point. From this point, point C, up to the cable is its widest point. So all we need to do in this case is put in a line here, and just indicate the height there, which is H. And there's no harm in measuring that height, measuring the length of that line there, just to be, and write that on. So 21.5 meters. So that's the height, that's the maximum height between the ground and the cable. Coming this way it starts to get narrower again, and again going this way it starts to get narrower, and this is less than, so this here is a height of 15, it's less than the 21.5 that's down here. So that actually completes part B of this question. So although it looks again very wordy and long, it's quite short. So part C of this question is on the map P and Q are 2 points on the surface of the Earth, so these 2 points here. Vertical boreholes at these points reveal the top surface of the stratum of ore at 50 and 35 respectively. A skew borehole at Q is drilled in an easterly direction and has an inclination of 55 degrees to the horizontal plane. It reveals the top surface of the stratum at an altitude of 30. So we can we'll be finding all of those points up here in a moment. In the space provided at the top of the map, draw the elevation of this triangular portion. So they're wanting us to use this space up here. Triangular portion of the top surface of the stratum, draw the plan of the triangle and determine the strike and dip of the stratum. So the first thing that we're going to do is we're going to locate points P and Q up here. So to do that I need to find points down underneath, altitude points, as some of the points come down to 35 and lower. I'm going to draw these in just to get the remainder of that. So we're told point P has an altitude, well, point P is on the surface, but the reveals top surface of the stratum at a height of 50. So that would be, following up along height here for P, that's this point here. So that's P, and we'll call it the head wall. So it's not actually P, it's the it is where it meets the stratum. Doing the same thing for Q, and Q we can see here is on the 90 contour where it breaks through the surface, but it meets the stratum at an altitude of 35. So that's this point here, so that's Q, head wall. So we have 2 points on our stratum, or there. Now we need to find the third one. So the third one is there's a skew borehole drilled in an easterly direction from point Q. So point Q is up here. I need to come up 5 more. Up here to the altitude of 90. So we can see here where Q is on the 90 contour, that means it breaks through the surface at this altitude of 90. So this point up here, that's point Q, it's on the surface, and we're going to draw the skew borehole here, which has an actual inclination of 55 degrees. So 55 degrees here, so I'm just doing it upside down, works the same if I have a 0 to line it up with. So 55, 0 here, measure around 55. From Q down to that point is, that's our skew borehole. and it reveals the top surface stratum at an altitude of 30. So that would be this point down here. Okay, so we can call that RH. That's where this Q borehole drilled from Q meets the top surface of that stratum. So joining all of these points together, so PH, QH and RH, joining three of those together, that gives us the triangle for the top, which is a plane on the stratum. And we're going to do the same thing in plan. Now at the moment I've only found P and Q, or PH and QH. I haven't located RH yet. So RH is, we need to draw the borehole at Q, so it's drawn in easterly direction. And we need to locate RH, so that's going to be directly below where it is in the elevation. So that's this point here, this is RH. That allows us to draw up the remainder of these. So that's the elevation and plan of those 3 points together to form that triangular portion of the top of the stratum. Again, we're asked to determine the strike and the dip of the stratum. So to draw the strike, we're going to take a horizontal line in the elevation. So it makes sense to take it from QH as it's in the middle. Just taking a horizontal line up here. This red line here, it's a horizontal line. As it's horizontal in the elevation, that means in plan it'll be a true length. Inflex the line coming from P to R. Started at Q. So this line here, the true length in the plan, that is the strike that we were asked to find. Final part of this then is to look along the strike. So we're going to need an X1, Y1 line. So that's going to be perpendicular to the strike. That's X1, Y1. Projecting each point out now same direction as the strike. So it's Q and P going out here as well. Heights are the same. So what we can do is, there's two ways you can do this. You can take RH as the lowest point, so RH here is the lowest point, it's an altitude of 30. So you can mark up here 30 millimeters, 35 and 50 from the X1, Y1 line. Or what you can do, just to condense this, just take RH as 0.0, so that's the point as in if our X1, Y1 or XY line was going through that point there. So RH would be on the XY line, QH would be 5 meters above that, and then PH would be 15 meters above that one. So it doesn't matter, it's all much the same. I'm going to do the actual height. So this here is at a height of 30, so that's RH. The next one is at a height of 35, QH, and finally PH there is up at a height of 50. So drawing a straight line between the three of these, that's an edge view of this plane down here, this surface. We need to find the dip, so you can either extend this line down here until it intersects with the X1, Y1 line, or just put in a measuring line. So the measuring line is taken parallel to the X1, Y1 line from anywhere along the edge view here, and that angle here, that's the dip that we're looking for. So that completes this question. So it's three kind of separate questions. You've got your kind of road geometry, but drawn as a ski slope, a profile with pylons, finding heights, that type of stuff, and then your mining geometry here to finish it off.